Hi, I'm Dr. Deb, and this is Sahifa for March 31st. I have the pleasure today of being with the winning, correct, Botball team at the competition that was held last weekend at Carnegie Mellon. Ah! So we have the 11 members of the team, and they won, which enables them to go to the International Championship in Anaheim, California in July.
Yes.
And I am here with the two sponsors of the group as well, DK Hipkins and Kim Tresolovi, who also deserve a tremendous... Now, what is Botball and what does this involve? Let's take a moment. We're going to ask DK and Kim to explain, and then we'll go and do introductions of the team, and we'll ask them to tell us about their robots.
Sure. Botball is a robotics competition that was set up by the KISS Institute for Practical Robotics to encourage students interested in math, science, technology, and all of the things that are the future in our world. The competition each year has a different theme. This year it's an airport renovation theme, and the board that you see here represents an airport. And on the board there are different tasks to be done, such as moving these tower blocks over to one area and stacking them scores a certain number of points. Getting the luggage, represented by the pink and green pom-poms, sorted into these containers and moving them to an area gives you a certain number of points. Being able to get Bot Guy, in the red over there, on top of our tower doubles the points for the tower. Being able to move the orange ping pong balls, which represent biofuels, over to the biofuel storage area over in the sides gets other points. And then we have airplanes, and then moving them to the runway so that they can evacuate or get out of the airport so that the renovation can take place. The competition runs 2 minutes per round, and it's whatever your robot can score in those 2 minutes. There's a morning component of seeding rounds where you play on the board unopposed. Then in the double elimination, you play head-to-head with another school, where you can cross over to the other side and do things to foil their robots, which is partly why our team won. As well, a big component is online documentation, where the students they create documents throughout the course of the competition where they are continually justifying the changes that they make, the decisions that they make, the designs, the strategies, and we went into the day with 100% in everything they had done in documentation up to. It's an 8-week competition, and it culminated Friday in the best result possible. Number 1 in double elimination and number 1 in winning.
Yeah, the whole process starts with the workshop that the students go to. We get to send 2 students over to Carnegie Mellon. They get to participate in a workshop where they learn about the programming. That's when they find out what the challenge is. And those 2 students then become the experts. And they come back and then they teach the rest of these guys and girl how this all, in fact, Nathan was one of ours that went this year. We're very proud of her for doing that. We send them over there, they learn this, they spend a weekend there, they come back, they know the task, and then we begin the process of figuring out how we're going to design robots to complete that task. Carnegie Mellon gives us a kit that has all the components that we need in it, except for the table. We had to build that ourselves. But they give us the robot components. We decide how we're going to construct it, or they decide how they're going to construct it. The first week is really nothing but a brainstorming session. Let's talk about ideas. Where do we maximize our points? Then after that, they go about the process of building, mostly building, but then we send a couple of programmers to work on starting to develop the programs that are going to run those. And then once they get the build pretty well done, by that time we've got this board ready, and so they're up here practicing. And the last couple of weeks before competition, what they're doing is rehearsing over and over and over again, finding out where the problems are, tweaking things to get them just right. And what we really saw was in our final 2 rounds at the competition, everything came together. And it worked out really, really nicely.
Well, let's take a moment and let's just go down the row and have every member of the team introduce yourself and tell us what grade you're in at ASD.
I am Saeed Sirhan, and I'm in grade 12.
Hi, I'm Ben Merkley, and I'm in grade 12.
Hi, I'm Adrian Bergdahl, and I'm in grade 12.
Hi, I'm Nathan Osler, and I'm in grade 10.
Hi, I'm Jonathan Savard, and I'm in grade 12.
Hi, I'm Taylor Hall, and I'm in grade 12.
I'm Barter Hansen, and I'm in grade 12.
Hi, I'm Pranay Sinha, and I'm in grade 10.
Hi, I'm Benjamin Chua, and I'm in grade 10.
So let's go to your two robots. Talk to us about the robots. How do you program them? What did you find out in terms of strategy with the robots? I mean, do they have names? Talk to us about the robots for a while.
This robot is called Titan, and mainly it can lift here with its main claw structure. And what it does, it drives up to a set of blocks and clamps them and then raises them up. So it leaves space for another 2 blocks, and then it can drop them on top like this. After the robot has stacked the blocks, it drives them up into this corner, and with this claw it grabs Buckeye, reverses, and drops it. And usually he'll fall on top of the blocks. And that scores a lot of points. This robot we call Carrier because it carries planes. The main structural feature of this robot is the claw at the front, which grabs the planes and then drives them and drops them onto the runway over there. And then after that it drives over onto the other side to stand in the way and block other robots.
Another essential part to the whole program is the programming of the robots, and usually it's very straightforward for completing the tasks, but there are also many issues such as calibrating sensors and following different things on the board. And because sensors are not always reliable, sometimes we program things directly to act as we want them. And this also causes problems because on game day they had 3 different boards that differed very minorly, but enough to change how our robots reacted. So over time, we began with, for that robot for instance, 500 lines of code, and by the end of the day in the last round it was down to about 100 lines of code, and it was almost completely changed through the course of the day. And so both of the robots had to be recalibrated and reprogrammed almost significantly to complete the task correctly by the end.
The Bot Ball competition this year hosted at Carnegie Mellon included 24 teams from 5 different countries: Saudi, Kuwait, Bahrain, Qatar, and the UAE.
Lebanon.
Lebanese school here in Qatar.
They count.
Oh, they do count. Now, when we go to California, we're going to be representing the Middle East region. So it's not just Qatar that we won, it's the whole region. And that's what's incredible. We are going to be one of 14 regions represented at the International Bot Ball competition. We will definitely be reworking and replanning our strategy, our designs, and looking to score as many points as we possibly can.
So even now, with as good as you did, you see changes that you need to make before the international competition. So that, for example, those balls the orange balls that you talked about that you weren't able to work as part of your strategy before, now you're going to be working on that.
Definitely.
And one of the real advantages we'll have is that Carnegie Mellon is going to send one of their official game boards to us.
Okay.
So that we'll have the real deal to practice on. We came as close as we could with this one, but we're really going to be happy to have that.
Now go directly to video from the winning 2 minutes.
The winning battle.
That's right.
All right. So last Friday, Carnegie Mellon, this team. Here we go. Thanks. This is Sahifa, March 31st.